Mr. Hevel, you have a calorimetry experiment for us today?
We do, Mr. Moore. We have calorimetry galore here. Absolutely. So, what we're doing here is coffee cup calorimetry and everybody's favorite, Hess's law. And here's what we're trying to accomplish here. We're trying to determine the enthalpy of formation for solid magnesium oxide. That's your goal. So, there's actually 3 different reactions that you're going to combine using Hess's law to calculate that enthalpy of formation for MgO. And it's important to remember how this is defined. Enthalpy of formation has a very specific definition. So you have to think about that definition when you're trying to come up with this equation.
So yes, notice we're not giving you what the chemical equation, the target equation for our Hess's law solution. You've got to come up with it.
Right.
Mm-hmm.
Okay, but think about the definition, and you can see what that equation is going to be. You're trying to find the change in enthalpy for this process.
Okay.
Now to do that, we're going to run 2 different chemical reactions experimentally using coffee cup calorimetry. And then you'll have to add in a 3rd equation that is the formation of liquid water. Now this one isn't experimental. You're just going to basically look that up. Okay? So here are our 2 reactions. Here's what we're mixing together. One reaction is solid magnesium metal with hydrochloric acid. It's going to react and make magnesium chloride and hydrogen gas. Our other reaction is solid magnesium oxide, again reacting with HCl, again makes MgCl2, but water in that case. Okay? Now you're going to have to figure out the net ionic equation. We gave you the molecular equation. You'll need the net ionic. Okay? And, hopefully you can read my blue writing down here, you're going to pick one of these reactions to be the basis of your particulate drawing. Okay, just one of these for your particulate drawing, whichever one you like the best.
Okay.
Okay?
So yep, we have these 2 chemical equations. Those are experimental ones. This one, you have to write the equation, come up with a delta H just from the table.
Right. So
Those are your 3 given equations. Yep.
Coffee cup calorimetry process will get you the delta H value for these 2. Okay?
Mm-hmm.
Now in the end, what you're going to do is figure out what's your percent error between the experimental value and the theoretical value for the enthalpy of formation of magnesium oxide. So over here, I don't know if you've dealt with percent error before. Percent error is the absolute value of your theoretical value minus experimental value over the theoretical value times 100.
You probably have used that before, but we wanted to just make sure you have it.
Exactly. Okay, and realize that you can look up the theoretical value for the enthalpy of formation of MgO.
Mm-hmm. Oh, here's an experiment set up for us.
Indeed. Here goes our coffee cup calorimetry experiment. And people love coffee cup calorimetry because it's dirt cheap, but it's accurate. And the heart and soul of that is our styrofoam coffee cups. And of course in Troy we use only the finest equipment for our students.
Students deserve the finest
They
equipment.
deserve the finest. And not only are we using 1 cup, we're nesting together 2 cups. And we have this precision-made lid. Okay, you don't buy these just anywhere,
No,
let me tell you.
it looks like it was made in America.
Yeah, made in room 302. And really, we're joking about it, but it is important because we're trying to insulate what's going on in the cup from the surroundings. We're assuming that we have perfect heat transfer in the cup, but the outside world is not influencing it. So. Okay, here's the thermometer we'll be using. I will point out it's Mr. Moore's favorite thermometer because it has blue spirit in it.
It is. All of our other thermometers are red. We used to have a dozen of these, but
Yes.
over the years, all of our, except one, all of our blue ones have broken.
Yes, this
And
is precious.
I really do want to cry when they break those blue thermometers on me.
Yeah.
But look at the graduations on this. We're going to have to get the best measurement we can out of that thermometer. And if you would focus, I'd be so happy. There we go.
Notice it's going up in 1 degree increments. That's important.
Okay, so we'll get that initial temperature of the acid when we're ready to start.
And here's our hydrochloric acid. We've already put it in the cylinder. Now this is 1 molar HCl. I just wrote it this way, but it's like 1.00 molarity HCl. And we're measuring out 50 milliliters. Maybe I'm better off leaving
Yep,
it.
we'll go sit that down.
Notice the graduations on this cylinder when you get a chance.
Oh, there we go. Yeah, it is graduated in single ml graduations. Bottom of the meniscus is right on the 50. So what do we say is the volume then of the hydrochloric acid?
All right, so we'll add our HCl to our precision coffee cup calorimeter. Now, the first reaction you recall involves magnesium nut. Okay, and so here we have a strip of magnesium ribbon. And let's get the mass for you.
Got it?
Okay. Now we're going to add it to the acid and see what sort of temperature change we get. It pretty much starts reacting right away. Giving it some gentle stirring to help distribute the heat. I don't know if you can hear the
Oh yeah, we
fizzing.
can even see a little bit of a vapor coming out of it. Oh yeah, yep. You get that fuming there because it was one of the products.
Yeah.
Hydrogen gas. Now, Mr. Hell, this is not
Yeah.
this is not the first trial that we've done that, and the other 2 trials we've done so far, that hydrogen has gone right up his nose. And if you don't know anything about hydrogen, it is not nice to breathe. It
No,
it hurts.
it
Like,
does.
it'll make you cough, make your eyes
Burns.
water, hurt
Yeah.
your nose.
Yep. Okay, I think it's got to be about done reacting.
Okay, so we're
I
looking
don't
for
know
the
if
highest temperature of
Yeah.
the thermometer. We didn't take the initial temperature of the.
Did we forget to
acid.
take the initial?
I
It's
just have to
okay.
tell you.
Well, you know what we
Oh.
can do? We can probably just stick it in here when we get done.
I was about to say what it was, but yeah, we don't want to let you off the hook with
Yeah.
any measurements, so yeah, we'll check that.
We'll get it for you.
Can you rotate that for
Oh,
me so we
sorry.
can see the numbers? Just slide over here.
Focus for you.
Yep. Okay, so there's our final temperature of the acid with magnesium. But let's go ahead and take that thermometer out of there and let it cool off, and we'll get the initial temperature, which we didn't get the first time.
Right.
Yeah, I mean, the acid has come out of this flask, so all of the acid initial measurements should be the same.
Yeah, you would think so. Is it okay if I just stick it in here?
Stick it right in there, that's fine. That's actually nice because it'll sit up nicely.
Let me get the drop out of the way.
Initial temperature for both trials.
Yep, there you have it.
Okay.
Okay. Okay, here comes our second trial. We'll have to again measure out 50 milliliters of our acid. Okay.
And we trust you. We don't need to zoom in on that. We trust that you've measured out 50 grams, 50 milliliters of the HCl. And reaction 2 is going to have magnesium oxide reacting with the HCl.
So let's weigh that out. Almost to 0. Okay.
What does that magnesium oxide look like?
Oh yeah, I forgot to show you. It's a very fine white powder. It's almost like flour.
There's the mass of it.
Okay. And same drill, we'll add it to the acid.
This reaction is not as dramatic as the first one because there's no gas given off. Everything just stays right in the cup. There is a temperature change.
Yep.
Hear that sink dripping back there? That sink drips all the time for years. And yeah, when it's real quiet, like when you're taking a test, those poor students in the back, drip, 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 drip. What does it look like in there?
It's still a little cloudy looking.
Yeah.
It should be about done.
Okay, yeah, if you can just hold it. Oh, okay.
Is it
Yep,
okay?
good. Oh, it's good. I'm not so good. There we go. All right.
Okay, now one final thing to note here, because people get confused on this every year. All right, this HCl solution is almost entirely water. There's a little bit of HCl in there, but it's almost all water. So when you use the Q equals MC delta T equation, you need a mass. Well, just pretend that this is pure water.
Mm-hmm.
We measured out 50 milliliters, so you should be able to figure out the mass of 50 milliliters of water.
So we're going to try to find the the experimental heat of formation of magnesium oxide.
That's right.
Good luck.